Lecture number 11, balancing chemical reactions. So now that we know how to name compounds and we can sort of start doing this mass conversion, let's talk about actually doing some chemistry involved in chemical reactions. So a chemical reaction is a process by which a substance or substances is changed into one or more new substances. So we're taking these molecules and combining them or breaking them apart to form new things. Right? So we write these, instead of representing them with atoms or molecules, we're going to use the chemical equations. We're using chemical symbols to represent these equations. So let's look at, primarily to start with, this reaction of hydrogen gas H2 with oxygen gas O2 to form water. It's one of my favorite reactions. It's explosive, it's fun, and we can see this, we can represent that by having two molecules of hydrogen reacting with one of these molecules of oxygen to form the two waters. Right? Or we can abbreviate it in the chemical equation as 2H2, those two hydrogen atom molecules, are reacting with that one oxygen molecule. Remember, hydrogen and oxygen are those special, they're diatomic. When you find them in nature, they are formed, those diatomics, those H2 or O2. And they're going to react together to form these two water molecules. So we're going to show it like it has here on the bottom. So when we're looking at these, the things that are on the left are going to be the reactants. The things that are on the right are the products. So before the arrow, we're taking those reacting together, reactants, and we're going to produce those things on the other side of the arrow, the products. So what we're going to look at today is forming these chemical equations and then making sure that the laws that we talked about before, those, especially the law of conservation of mass, is followed. So we have the same amount of material at the beginning of the reaction as we have at the end. But let's take a second and look at these, interpret these chemical equations. So if we take another reaction where we take two magnesiums and react it with an oxygen molecule to form two magnesium oxides, we can say that that's two magnesium atoms reacting with one molecule of O2 to form two molecules of MgO. We also said that there's this relationship, we can talk similarly between molecules and moles, so this relationship can also be 2 moles of magnesium reacts with 1 mole of oxygen gas to form 2 moles of this magnesium oxide. Or we can say that we can take that number of grams, 48.6 grams of magnesium, reacting with 32 grams of oxygen to form 80.6 grams of magnesium oxide. So when we look at these chemical reactions, we're either talking about a relationship of atoms or a relationship of moles, right? We're not, and any mass that's involved has to be either the mass of those atoms, AMUs, or the mass of the moles, the molar masses. So it's not 2 grams plus 1 gram, it's not that. We're always talking about either atoms or moles. So if we're going to look at following these reactions, balancing to make sure this law of conservation of mass is followed, then we have to have the same amount of material at the beginning as at the end. Since these atoms themselves can't change, what we're really looking at is making sure we have the correct number of atoms of each type in the reactants as we have of atoms of the same type in the products. So we're going to maintain the total number of atoms. We might rearrange them, but the total number of each type of atom is going to remain the same. So the way we balance these chemical equations is we always start with an unbalanced reaction. So we take from the names, we write a correct formula. So this is what we've been working up to, right? Getting these from the names to a chemical formula, that relationship. The things that are listed in the left side are the reactants, the right side again are the products. So if we take, for example, ethane reacts with oxygen to form carbon dioxide and water, chemical formula for ethane is C2H4. Oxygen, again, oxygen is diatomic, so it's O2, forms, or the reacts, which is going to lead us to the arrow, carbon dioxide, CO2, and water. So now here listed in yellow, we have this unbalanced chemical reaction. We just have the molecules themselves. So our process we're going to go through now is to balance that, make sure that masses are the same. So the first thing we need to understand is that we always change the numbers in front of the formulas, what we're calling coefficients, to change the number of molecules instead of those subscript which indicates the number of atoms. Right? So, for example, if we're going to multiply by 2, we'd have 2 C2H6s, not C4H12. By changing the subscripts, we've actually changed the chemicals. Right? The number in front just tells us we're having multiple of those react. So we're going to follow this through now. So the first thing we're going to balance is things that only appear in either a reactant or a product, or one of the reactant and one of the products. So if we look at here, we have carbon is only in the ethane and only in the carbon dioxide. So it's only in one of those, so we're going to start there. Where oxygen is in 2 different ones. So if we look at the reactant side, we have 2 carbons. On the product side, right now, we're only showing 1. So we have to take care of that by multiplying, saying that we have to produce 2 carbon dioxide. So we're going to put a 2 in front of the carbon dioxide. Then we're going to go to hydrogen. We look at hydrogen. We have 6 hydrogens on one side, only 2 hydrogens on the other. So now we have to make those equal. So 2 times 3 is 6. So we can multiply the oxygen or the waters, by 3. So now we're going to have C2H6 plus O2 gives us 2 carbon dioxides and 3 waters. So now our carbon, the amount of carbon we have on one side of the reaction is equal to the amount on the other. The amount of hydrogen we have on one side of the reaction is equal to the amount we have on the other. So now we have to worry about that one where we have atoms in more than one case. So we're going to balance those charges that appear in 2 or more reactions as our 4th step. So if we look on the reactant side, we have 2 oxygens. We have a total now of 7 oxygens on the products because each carbon dioxide gives us 2, but there's 2 carbon dioxides, so the carbon dioxide brings 4 oxygens. Each water brings 1, but there's 3, so that gives us 3. So 4 plus 3 is 7. So we now have to balance that. On the other side, we have to have 7 halves of that. So we can say this balanced reaction is C2H6, 7 halves oxygen forms 2 CO2 plus 3 waters. If you don't like the fraction, we can simply multiply that fraction away by multiplying both sides by 2. Right? So this is the process we're going to take when we balance these reactions. We're going to make sure we have an unbalanced, correct chemical equation. So we're looking at the formulas for everything. Reactants on one side, products on the other. We're going to only change the coefficients, those number in front, the number of molecules. We're not changing the molecules themselves. We're going to balance things that are only in one reactant and one product first, and then go back and look at things that are in multiple. The sum of the things we have in the reactants has to be the sum of the products. And finally, we're going to then check this. If we see we have in the reactant side, we have 4 total carbons, 12 hydrogens, and 14 oxygens. On the other side, in the product side, we still have 4 carbons, 12 hydrogens, and 14 oxygens. I don't necessarily think you need to form this summary table, but I always, myself, and suggest you also take a minute, once you think you have a balanced reaction, go back and check. Check a couple of atoms and make sure that the amount you have in the reactants is equal to the amount we have in the products. So now that we can name these, we're going to take these balanced chemical reactions. We're actually going to start doing some chemistry. We're going to look at how we can convert reactants to products. Now, in the next lecture, we're going to talk about doing that in terms of masses and moles. Right now, we're just going to start with balancing.
Dad, I done did it.